Right. So the BJT regions of operation include four regions, no? So we list this down, no, in terms of yung biasing nung VBE versus yung ng CB junction versus ng BE junction, right? Kasi if we remember correctly, no? Sige, isulat natin yung BE and CB na junction. So for forward active, isulat natin ang buo. So for forward active, kailangan yung BE junction is forward biased. Yung CB junction is reverse biased, no? Because in forward active, kailangan the current, no? The carriers rather. So let's say pag ganun siya. So let's say this is the valence band edge, right? Kailangan yung main carriers natin, they're able to diffuse across to the base, no? So this is your emitter, your base, your collector, di ba? And this is P plus, this is N, and this is P again, no? Bakit PNP? Kasi, um, well, because of the shape of the valence band, right? If we were to place EF like somewhere up here, no? Like a dashed line dito sa taas, if this were EF, then you could see na, um, well, relative position niya sa EI ang magmamatter, but you can see clearly naman na bumababa si EV sa gitna, no? Which means na um, the uh, the EF clearly crosses across the EI. Sige na, drawing natin buo. Yan. Easy. Tapos, lagay natin yung EI dito. Then we're gonna place down locations for the EF, which is here, mali, here, ayan. So, it's now clear, no, the PNP BJT to, no? Now, we desire na forward bias to at reverse bias to for forward active because we would like the diffusion of carriers from here, no, from the emitter, we would like them to make it across to the collector um, via drift, no? So magdi-diffuse sila dito, and then once they get over here from the diffusion, the drift that's caused by the slope in the energy band diagram causes them to reach the collector in this case, right? So this is forward active. Kapag forward yung EB junction, reverse yung BC junction. Do note na nagbabago yung order ng pag-refer natin dito sa mga junction na to based on kung alin yung typically mas mataas yung ah, voltage, no? So essentially ang mangyayari lang is EB junction ang tawag natin for PNP. Bakit? Kasi yung Shockley well yung BJT equation natin for the PNP is E to the VEB over VT, right? So ito yung equation natin. So we just refer to the junction with this, no? Kasi we expect na sa forward active, the E is of a higher voltage than the B for AT&T BJT, no? As opposed to that, sa NP and BJT, mas mataas yung voltage ni B kaysa kay E for forward bias, no? Same din dun sa BC junction, ang tawag natin is CB, no? Just because mas mataas yung voltage kay C kaysa kay B for forward active, no? So yung naming convention natin dun sa pag-refer natin sa pangalan ng junction depends on kung alin yung mas mataas yung voltage in forward active, no? So the naming convention actually depends on the naming actually depends on the forward active voltage, no? So that's forward active, and that's what we discussed before, no? That's what we discussed in person last time. So ngayon, we have the other regions of operation, and let's start with, let's copy paste this. And let's do all the examples with a PNP junction. No? So tatanggalin natin to. All right? So next, let's talk about cutoff, no? In cutoff, yung EB junction natin is reverse bias and yung BC junction natin is also reverse biased. So on a BJT, what this would look like is probably something like this, no? So kung ito yung emitter, ito yung base, at ito yung collector, no? And this is a PNP BJT, the base would be higher than the emitter, no? So VEB is positive, VEB is negative, rather. Like pala to. VEB is negative, and VBC is also negative, no? So actually, in reality, we would see minus here, a plus there, and minus here and a plus there, no? So ang pinakamataas na voltage natin is nasa collector, no? So in this case, ang magiging itsura ng energy band diagram natin would be something like this, no? So for the valence band edge, right? Actually, it would be much more strongly reverse bias for that one. But essentially, the point of cutoff is the fact that diffusion is no longer possible. Because we know this, no? From reverse bias, right? We know, right, na in reverse biased PN junctions, the diffusion current exponentially decreases, right? Until na mawala na siya, tapos drift current na ang nag-dominate, no? So in much the same way, yung PN junction natin now suffers from yung BJT natin now suffers from the same fate kapag kinut off natin siya. So if we draw the other parts of the energy band diagram, the conduction band edge would be up there. EI is always directly in between. Tapos, EF would be here, no? So EF would still be here for the P plus side, no? For the emitter. This is the EF of the emitter. This would be the EF of the base. And this would be the EF of the collector, no? And we can see the required biasing here, no? So we see, no, that EFE is actually higher than EFB, meaning that the voltage at E is less than the voltage at B, right? Or in other words, VEB is less than 0, no? So this distance in the energy band diagram tells us all of this. Much the same way, no? The distance between the EFB and the EFC, no? The fact that EFC is higher than the EFB tells us that the voltage at C is less than voltage at B, right? Which tells us that VCB is less than 0 dito, right? So drawing or remembering what the energy band diagram looks like for cutoff allows us to remember what the required DC voltages are to achieve cutoff, no? So anyone have any questions about cutoff? Right. So other traits of cutoff, aside from just the energy band diagram, no, is that in cutoff, IB is typically 0, no? IC is also typically near 0, no? Or rather, actually, most of them will be in near the saturation current IS, right? Kasi ang makukuha mong voltage dito is the voltage from, ang makukuha mong current dito rather is the current from drift, right? From the reverse bias PN junctions, no? So this would be IS, no? Which also would be IE approximately, no? Though in practical circuits, right, kapag ginamit natin to, tapos naka-IB equals 0, then naka-off yung BJT, right? And we essentially get nothing from it. It's an open circuit, di ba? So this is essentially an open circuit because no matter what voltage, no, it doesn't matter what the voltage difference is between E and C, so long as B is that far down against either of them, walang current na magpapass, right? So this is an open circuit. So that was cutoff. All right. So next, saturation. So in saturation, both junctions are forward biased, no? So ano magiging itsura niya? As opposed to this, it's gonna get flatter, no? So it's gonna have small barriers on both sides, di ba? 0.2 volts, VCE equals 0.2 volts, VEC equals 0.2. So it has to be slightly higher. Diba? Wait lang ah. Let me remember, no? So for PNP na naka-saturation, this is also still 0.2 volts. Right? So mas mababa ng konti. See? E kaysa kay C. Right? But actually, sige, let's forget the 0.2 volts for the purposes of illustration. And then let's label this one. Alright? So yung mga EF natin, relative to the flat energy band diagrams, it would still be here, no? So this is your EFE, this is your EFB, and this is your EFC, no? Then, ang makita natin dito is now, alright, so note, no? Mababa yung energy barriers kasi forward biased parehas, right? Tapos, other notes probably, let's find the light green color. Yan. So we can see this difference, right? So that difference means that EFB is greater than EFE, meaning that VB is less than VE, or that VBE, or rather, VEB yung positive voltage natin, right? For a PNP, this is a condition for the forward biasing of the VE junction, right? Kasi ito yung P, ito yung N, no? Mas mataas dapat yung voltage ni P kaysa kay N. For this one as well, no? We have that EFB is greater than EFC. So we know that VB is less than VC, or that VBC is negative, no? Or VCB yung positive voltage natin, no? Which makes sense kasi kung ito si P, ito si N, no? Kasi P and P, then dapat pag ganun siya para forward biased, no? So back to the carriers, no? Anong ginagawa ng carriers dito? So the carriers are free to move that way, right? From the collector as well, the carriers are also free to move that way, no? So, saang direction sila in general pupunta? Well, for a BJT in saturation, what essentially happens is this becomes a sea of carriers, no? Which can go any which way depending on the voltage applied across here, no? Or in other words, no? In saturation, In saturation, the BJT has low resistance, no? Or it's in the on state, essentially, is what we have, no? We don't tend to like saturation either because it doesn't have the same amplifying properties as forward active does, no? Because now, when you apply a current to the base, it doesn't relate to the currents in C or E, no? So that's a problem there, right? Next, we have, ano sunod? Okay, so lastly, we have reverse active, right? So for reverse active, it is just the opposite of forward active, no? Essentially, ang mangyayari, ganito yung junction natin. So we have P and P, right? P and P. So, reverse bias, medyo masyado malapit. Reverse bias, itong unang PN junction, no? And then forward bias, itong pangalawang PN junction, no? Between the collector and the base, kasi ito si emitter, no? So the EB junction is reverse biased, and the BC junction is forward biased, no? So whatever carrier action we had is going to occur the other way around. So ano mangyayari dito? This electron can diffuse over here and fall down into the collector, which collects the main carriers, no? Yun yung action niya. So EFE is still here, EFB still here, EFC also still here, no? Note na similarly to what we had dito sa taas, no, for forward active, pataas yung hagdan dito sa forward active, no? Because the voltage rises, no? And the voltage gets lower as you go from E to B and then to C, no? So if the voltage rises, the energy, the voltage rises, the energy, so the energy rises here, so the voltage gets lower, no? The voltage gets lower pala, rather. No, the voltage gets lower as you go up along here, no? So dito naman, ang may pinakamataas na voltage is si C, no? And then si B, and then si E, right? Kasi gusto natin forward bias to, gusto natin reverse bias to, no? So anong ginagawa ng reverse active?
Would you prefer to come to the report first or last, depending on the capacity?
So ang ginagawa ng reverse active is like forward active but worse, no? I've said this before. It's forward active but worse. Saan galing yung worse na part? Ito, no? So, i-compare natin, no? So, remember this drawing. And let's compare it dun sa drawing natin ng forward active sa taas. So, ito yung reverse active natin, no? So, dun sa forward active, I drew a 3-layer pyramid of carriers, no? To symbolize na there's a lot of main carriers na galing sa emitter, no? Now, if you do that for the reverse active case, right? We only have not as many holes in the collector, right? So what happens is that the injection, no, of majority carriers from the collector into the base is not quite as good as the injection from the emitter to the base, no? Which means that we have around 10 times to 100 times less current kapag reverse active natin ginagamit yung BJT, no? It's around 100 times less IC versus forward active, no? So essentially, that's the summary of the BJT operating regions, no? So question, sir, bakit po ba ulit kapag mas mababa EF, mas mataas V? Alright, so let's go back to that one. So, um, for example, no, we have a PN junction. We have a PN junction na naka-forward bias. Let's try to make it forward bias. So this one here is N. This is the EF of the N part. This hindi siya biased kapag ganito dinrawing. So let's make it less. Yeah. So we have a forward biased PN junction here. Tapos yung voltage difference of interest natin is ito, no? Now, a fact that we know is that QV, no, negative QV is equal to potential energy. No? And we knew that if you promote an electron from down here, right, it jumps up here. But if you give it just enough energy, which is equal to the band gap, no, then it's stuck here, right? It doesn't have kinetic energy. So essentially, we can interpret potential energy as the amount of energy that an electron has in the conduction band, right? So what we get from this is that if you increase the voltage, bababa si EC because they're complete opposites of each other because this is minus, no? So V is opposite E, right? So if i-flip mo lang siya. Because of the observations natin sa potential energy and definition of the energy from voltage. So it's because of this negative Q. All right? So because of that, no, ang nangyayari, so for E, no, so since EFE is greater than EFD here, we know that VE is less than VD, no? Kasi from E, you went down in the energy graph, which means that you went up in the voltage graph, right? Kasi kapag sinulat natin yung voltage graph, it would curve the opposite way of that thing, no? Kulang sa space. But it would curve the opposite way that thing did. So, gaganon siya, tapos gaganon. Right? Sige, so anyone else have any questions about regions of operation? All right, sige. So, if not, let's move on to part 2, no? So, Right. So I'm going to draw here a PNP BJT. Tapos, kaka-paste ko, paliliitin ko, and I'll save that there. Para hindi nawawala. Ayan. Alright. So this is the um this is the P part. It actually is the P plus part, which is the emitter. The N part is the base, and the P part is again the collector. No? So bakit alam natin na emitter to? Because it has a higher doping, no, than the collector. All right. So for a PNP BJT, ano ang main carrier natin? Holes, no? No? So holes ang main carrier natin, no? And we know na forward bias to, di ba? And then reverse bias to, no? So we know that if I were to draw, no, the movement of holes, right? There would be a lot of holes going here, no? There's a lot of holes going into the base from the emitter, di ba? This is because of diffusion, right? In forward active. Likewise, there's a lot of, well, there's quite a few, no? Not that much more, but, well, not that much actually. We tend to minimize this, but there's quite a bit of electrons coming in, no? Bakit? Kasi nagdi-diffuse din naman the other way around yung electrons, right? So this is our carrier flow across the EB junction, right? This is a forward bias PN junction, which causes diffusion of both holes and electrons both ways, no? Ang tanong, bakit mas malaki yung current for holes? Kasi P+, no? The emitter has way more holes than there are electrons in the base, no? Even though ang majority sa base is electrons, the bigger majority is in the emitter, which is the holes, no? So kapag forward bias natin, there's a lot more holes that will diffuse from the emitter to the base than there are electrons in the base that will diffuse to the emitter. All right? So, well, from the story earlier, we know na itong holes na to, they move on to the collector, no? And this is drift, no? Because they accidentally get to the junction, tapos nasi-sweep sila across. And this is a reverse bias junction, which means na sobrang lakas ng electric field dyan, right? So they get swept across via drift, no? The thing is, though, na not all of the holes from the emitter actually make it to the collector. Some of them actually recombine. Bakit? Kasi minority carriers sila. Like, there may be a lot of them, but there's still minority carriers dun sa base, right? So, some of them may be able to avoid recombination, but a lot of them may be able to avoid recombination kasi maikli yung base, but some of them will still fall victim to it because there's still minority carriers in the base. No? they meet an equal amount of electrons in the base and get happily recombined, right? So that is that is another thing that happens in the base, no? Which is why, right? We know this equation, no? So IC is equal to IE minus IB, no? So the current that we lose in the base is actually from recombination, no? So from here, we can actually identify some interesting things, no? So, oops. Oh no, okay, let's close it. And then open it again. Yeah. So they meet electrons happily in the base again. Yan. So in-erase nila yung IE ko. Sige. Let's do the analysis again, no? Itong IE na to includes both itong electrons na to and itong holes na to, no? So that's IE. IC includes this thing, no? So itong whole current na to, that's IC, right? So then, IB is actually this current that is lost in the base through recombination, no? And the thing is, kapag nagre-recombine yung holes at saka electrons, of course, hindi naman mauubusan ng electrons si base. Kasi meron tayong bakal na nakakonect kay base, right? We have a metal here, no? That's why it's a three-port device, no? So yung electrons mo actually in a PNP device come from the wire, no? So this is your IE, IB, and IC in a forward active junction, no? Right. So let me erase that one first, no? So final part of this diagram is actually here, no? It's here. Kasi sabi natin, di ba? BC is reverse biased, right? This BC junction is reverse biased, which means that we can have a current of holes, no? Just from pure coincidence, drift that way, no? Of course, we can't measure this because it's drowned out by that, no? So it's like the workforce riding the MRT and the people who just want to ride the MRT for fun, no? I'm sure they exist, but we don't know who they are, right? And there's much less of them. But we should also note kasi na may electrons din na nagdi-drift the other way around. Right? Ay, wait lang. Baliktad. Minority. Sige, let's draw that again. Tama. Sige. Ayan. So, the electrons drift, no? The minority carrier electrons that find themselves in the collector, they wander too close to the junction and they accidentally get swept across, no? The minority carrier holes in the base find themselves in the junction and get swept across, no? So this is your IO of um, the BC junction. Is your reverse saturation current, no? For the PN diode, that is the BC junction, right? And with that, those are your current components for the forward active carrier flow, no? So really, the things to note is that um, diffusion, so we have diffusion in the EB junction, which goes to, okay, yeah. So we have diffusion in the EB junction. These are your two arrows up here, no? We have recombination. Recombination in the base, no? Actually, sige, let's write this as IE na because it is, no? Recombination in the base causes the base current, of course, no? Plus this electron portion, no? So actually, let's call this IB2, no? So that's current due to recombination in the base, no? We also have the um, collector collection of hole from emitter, no? That's this part, right? And we have, no, the reverse bias CB current, no? Which is this part, right? So these two form IC. Now, bakit ko tinawag na IB2 to? No? Well, that one is actually right here, no? So that's IB2. Tapos ito yung isa pang IB, no? So that's IB1. Kasi of course, kapag nag-diffuse yung electrons from the base to the emitter, of course, it has to be replenished as well, right? So then, the IB total is the IB2 plus IB1 equals IB, no? And now IC is equal to IE plus IE minus IB, right? Kasi it loses current in the base, no? So, um, that's it for the forward active carrier flow, right? Anyone have any questions about the carrier flow? Sige. Sige, just to emphasize the point again. So let's do it again. Try to see if we remember. All right. So this is a P plus NP device where this is forward biased and this is reverse biased. No? So ang pangyayari dito is because of the forward bias, malaki yung diffusion current dito, no? But because of the fact that this is P+, mas malaki yung hole portion kesa dun sa electron portion, no? Because the base is narrow, a lot of the current make it to the collector, no? But not all of it. Some of it recombines in the base, no? Which tells us that the base current is made up of the recombination current and the electron diffusion, IB1. Alright? So yun na, halos buo na yung story. All we have to add is the fact that minority holes get swept like that and minority electrons get swept like that because of the reverse bias current. No? So yun lang siya. A thing that we can note, though, is this fact. No? We have a P part of the base current. We also have an N part of the base current, right? And we said that the P part must be quite a bit greater than the N part because of the fact na P plus to. No? That's true. Now, this thing leads us to our next lesson, no? How do we, naisulat ko ba dito sa taas? Hindi pa. All right. Anyway, the next lesson is performance parameters, right? We have 4 of those, no? We have beta. We have, okay, let me pull up my cheat sheet just to make sure I'm not wrong. Alpha, alpha T, and gamma, right? So wala na tayong Roman alphabet dito. Lahat Greek, no? So, let's talk about beta, no? Beta is stems from the fact. Let me just clean up this this chart. Oops.
Contract agreement.
Yan.
Refund cannot find it very
So,
well. Is it
it stems from the fact that this is IC, right? And this is, bakit B yan? Oops. Yan. IC comes from IE, right? And IEN pa ganun din naman. Kaso pa ganun yung flow ng electrons, right? IE turns into IC, right? But it loses something along the way, no? Which is the IB2, right? The beta is something that you probably already know because it's part of basics of BJT, but it's IC over IB, no? No? So essentially, it measures the number of carriers lost or the proportion of carriers lost in the base. Kasi nga nagre-recombine yung carriers dito. No? That's what beta does. Next, we have alpha. No? Alpha, ay, carriers lost in the base. Hindi pala, no? Baliktad yung discussion ko. Sabog. Alpha is IC over IE, which is the one that measures loss in the base, no? The thing about the IC over IB, no, yung beta, so let's go back to beta, is the fact na proportional kasi itong number of carriers recombined in the base is actually proportional to the strength of IE, no? Because if there's more carriers passing through here, right? There's more carriers that are going to be lost in the base, no? Which shows us that since both of these, no, so IB2 and IB1 grow as this thing grows as well, no, then they're exactly proportional, no? So there is some constant of proportionality that relates the current received at the collector, no, to the current that's received in the base, no? Because this recombination current increases as you get more IE. This backwards diffusion current also increases as you increase IE, right? So then IB and IE are also related by a constant of proportionality, no? Which is beta plus 1, right? Which also further leads to the fact that IC over IB is beta. No, we just like working with IC more. That's why we define beta in terms of IC, not IB. But the reasoning behind why this beta is constant for a BJT is, it stems from the fact nga na this recombination and this reverse diffusion is both proportional to this whole diffusion. No? So I hope that one makes sense. Yung alpha naman, again, as I mentioned earlier, no, is due to this part. No, we don't want to lose too many things to this part, which is why we measure the amount of IC that we get versus the amount of IE that we put in. No? Now, interesting thing about this alpha is the fact that, di ba, we measure alpha with respect to how many things, how much current we lose in the base, no? But that's kind of the same thing as the measure that we use for IB versus IC. Kasi, ito is proportional to IE then, right? So actually, these two parameters, no, the beta and the alpha, are related to each other, no? In fact, alpha is actually beta over 1 plus beta, which tells us something. All right? It tells us, no, na if this beta, so okay, fun fact lang dito, beta tends to be in the let me write this in the more correct terms. Beta tends to be in the range of 100 to 200. No? Actually, 50 to 200. 200 is quite great na. That's a very nice BJT. But it means na, since it's alpha is beta over 1 plus beta, we expect this number to be like, I don't know, parang 95% to 99%. No? So beta is a number in hundreds, but alpha is like a number that's better as close that the closer it gets to 1. No? Kasi it's beta over 1 plus beta. Right? So next we have the alpha T. No? So alpha T is the base transport factor. And to be honest, it actually does measure the same thing as alpha, no? But it's a little less useful in terms of the general circuit analysis, no? That's why they're both the same symbol essentially, right? This one is the same as um the alpha, but it's just concerned with the main carrier, no? And so this one is just concerned with the main carrier, no? So this one is concerned with both the electrons and the holes, no? It measures both the electron hole current of IC and IE, but this one it measures only the main carrier, no? So for PNP, this is ICP over IEP. For NPN, this is ICN over IEN, right? And it also measures the amount of main carriers, no? Main carriers na lang, the amount of main carriers lost in the base, no? So lastly, we have gamma. Gamma is called the emitter efficiency. Well, alpha T is called the base transport factor. So it's the factor that records how safe it is kind of to transport yourself across the base if you are the main carrier, no? Which it's not so safe because some of them do end up recombining. The gamma is the emitter efficiency. So it's a measure of how much main carriers make up IE, no? So then this is equal to IE of the main carrier, no? So for PNP, this would be this over the total IE, no? So for PNP, this would be IEP. For NPN, this would be IEN, no? And IE is just equal to IEN plus IEP, regardless of the type of BJT, right? So those are your performance parameters, no? For now. So for now, definitions pa lang yung meron tayo dun sa performance parameters, no? But we will see, no? I'm going to have examples, well, an example, no, of how to use these, no? So, so far, does anyone have any questions about these? Right, sige. So, if there are no questions, let's move on to an example, no? So, let's say we know what IE, we know all of the performance parameters. We know gamma, we know alpha T, we know alpha, and we know beta, no?
So very similar to
So, if we know these, actually, we can relate all of the, we can derive all of the other current components in the BJT, essentially, no? So, for example, um, in an NPN BJT, no, I am given IEN, no? And what I want to find is IC, no? So just from the performance parameters, we immediately know what IEC is, no? So IEN gives us the main carrier, right? Which means that alpha T is actually equal to IEN over IE, no? Or in other words, no? IE is equal to IEN over alpha T, right? Or rather, mali, gamma, right? That's gamma. So IEN over gamma, no? So we can see that there, just it's gamma. So since we know that IEN over gamma is IE, let's use alpha as well, no? Because alpha connects IC with IE, di ba? So since alpha connects IC with IE, we can get IC from IE just from alpha, no? Which means that alpha over gamma times IEN gives us IC. All right? So that's one example, no? Eh paano pala kung IEP yung given sa atin, no? For an NPN BJT. So this is your emitter minority, right? This is the minority carrier for the emitter, no? So it's not explicitly present in any of our equations, right? Because gamma is IEN over IE for NPN, no? Kaso note that we can do this, right? IEN over IEP, yung IE na total, right? So then, gamma IEN plus gamma IEP equals IEN, no? Or in other words, sige, sino gusto natin kunin? We want to get IEN from IEP. So IEP is equal to lambda minus 1, gamma minus 1 times IEN equals gamma IEP, no? Negative. Tama. So we can just flip the signs for now. Hindi ko ma-erase. And 1 minus gamma equals lambda IEP, no? So then, we can get IEN from lambda over 1 minus lambda at gamma. Gamma over 1 minus gamma IEP, right? So if we wanted to get IEN from IEP, we got that na. And to get IC, no, we just need to substitute that there, right? So the equation would be like this, no? So actually magka-cancel yung dalawa. So we have alpha over 1 minus gamma IEP, no? So we get current components from that. All right. So if you have attempted the second quiz, which I hope wala pa kasi hindi pa natin na discuss yung lesson, no? Ngayon pa lang natin discuss. But this is generally how you um do that kind of problem, no? Kasi if we were to connect all of those variables, no? So IE, IEN, IEP, no? IC, ICN, no? Tapos ID. These things are all obtainable from each other given the performance parameters, no? So given these performance parameters, itong apat, you can always relate these things to each other. All right? So does anyone have any more questions?
I also see in him curve, trying to wait for him.
Right. So unitless po ba ang mga parameter? Yes. No? So itong mga parameter na to, they're all unitless. Why? You can see here, no? It's amperes over amperes right here, which is unitless. That's alpha t. This is also amperes over amperes, which is unitless. Okay, this is sige. So this is also unitless, no? Kasi amperes over amperes siya. So all of them are amperes over amperes, which is which makes them all unitless. Right? So let me prepare the link for attendance and let me send it to everyone. Hindi pala tayo nag-break today, which is why hindi ko na-send ng mga ganyan attendance. Ayan, so please check the chat and or Discord to go find the attendance report form, and with that ends our lecture for today, and see you guys next week.
Thank you, sir.
Thank you po, sir. Thanks, guys. Bye-bye.
Thank you po, sir.